So till now we have understood how AMQP protocol actually works and what kind of model it actually expects, right? But now what we will see is we will see something specific to RabbitMQ. Now we will understand how this RabbitMQ actually works and uses AMQP protocol. So this has various components which has exchange, which has queues, and this consumer and publisher, these are clients for this RabbitMQ, because this is somewhat related to your applications that you have designed. So this publisher will be defined, this code will be written in your application in order to send a message to this RabbitMQ, and this consumer is also written in your application, another application that you have written, and this consumer will act as an interface between this broker and your application in order to receive the packets that are coming from these queues. And this publisher will act as an interface between this process and broker in order to publish messages from this process to this broker. So first thing that happens is this publisher will try to make a connection with this broker. Okay, it will try to make a connection here. And how this connection will be established? First of all, you will be using certain programming language here to write the code of this publisher, and you will also have a client library here which you have installed according to your programming language. So you will call the function of this client library like make connection to this RabbitMQ by providing the host. Suppose let's say the IP address of this server on which RabbitMQ is running, it's suppose let's say 172.3.2.1. So you will specify the host, and you will also specify the protocol as well, which is AMQP in our case, and your client library will also be dependent on this protocol also, because the client library is also defined in such a way that it satisfies your programming language and this protocol and the broker that you are using. So you will specify the protocol AMQP, then your host, and you will say that client library please make a connection with message broker. So what the client library will do is it will make a packet at application layer which will have certain information about this host, this protocol, and this several things over here, and it will make one packet, and then it will be passed over to 7 layers, another 6 layers of the OSI model. So this is done. Now each layer will add certain more information. Now if I talk about this transport layer, so this is application, then presentation, then session layer, and then transport layer. If I talk about this transport layer, this AMQP uses TCP protocol at transport layer. Okay, it uses TCP protocol. And why I am discussing about this TCP protocol here, because this plays a very important role here in order to understand how this connection is established. Okay, and of course here you will be at networking layer, you will be using IP protocol, but we will not talk more about this. We will talk about this. This is a transmission control protocol, and this is a highly reliable protocol. Highly reliable. And why highly reliable, I will talk about that later. So this packet that you have created at this application layer, it will move to this layer, and certain more information will be added at each layer. And now this transport layer, what it will do is it will also add certain more information in this packet to make a connection, right? So in order to make a connection, what will happen is, and if I talk about this TCP protocol, when you make a connection with a server using this TCP protocol, what generally happens is, this is a lifeline diagram, and if this is a publisher and this is RabbitMQ, and if you are making a TCP connection, a socket connection over this TCP protocol, what will happen is, first a TCP packet is sent, which is basically a SYN packet. Okay, SYN, and then this RabbitMQ server will send an acknowledgement, which is called as SYN acknowledgement, and then it will again send an acknowledgement in order to ensure that a connection is established. So basically at this point TCP socket is established, TCP socket connection. is established at this point. So this process is called as TCP three-way handshake, or we can say it's called as TCP connect, which has one SYN packet and 2 acknowledgements. So this is necessary. So in order to make a connection, first these 3 packets will interchange between this publisher and RabbitMQ, and once this TCP connect is established, then after that certain more packets which are specific to this RabbitMQ, which are specific to this AMQP, sorry, which are specific to this AMQP protocol, certain more packets will be added over here. Suppose let's say this is a RabbitMQ, so it will again send some packet over here, and then it will again do something. So the total packets that are necessary for making a connection are 7, and 7 do not include these acknowledgements. Okay, it do not include these acknowledgements. It only includes the main packets. Okay, if we add acknowledgements, then it will be more. All right, and this TCP connect is basically somewhat specific to this TCP, and your operating system will take care of that, because at this layer your client library is not actually working. At this layer operating system actually works, the code written over here. So this involves 7 packets plus acknowledgements, and since this TCP has acknowledgements, that's why it's called as highly reliable. So what happens is, whenever we send a packet using TCP protocol, it first has to receive acknowledgement. Only then the server who is sending a packet can actually send another packet to the server. Okay, and only after this TCP connection is established, only then you can send another packet. Suppose now this RabbitMQ wants to communicate with this server, so it will send a packet, but now this publisher will have to again send an acknowledgement over here. All right, so everything involves acknowledgement here. That is the beauty of this TCP. But because of this acknowledgement, this is little bit slow, but it guarantees reliability. In case this acknowledgement is not received over here, or because of some packet loss, or the server is down or anything, then it will again try to send the packet again. So it will ensure reliability. But still it's possible that this connection is, if this connection is broken, suppose let's say it made a connection and now these 2 servers are communicating with each other, and now this TCP connection, this connection is broken. So it's possible that the packets will be dropped because of this also, and this case has to be handled by your code that is written over here or here or here. It depends on totally the applications that are developed over this. So you will have to take care at these layers. Okay, so that is what we are going to discuss about this in this video. So connection is established, and for making connection, minimum 7 packets plus acknowledgement. But if you are using TLS also, which is SSL protection also, in order to encrypt the message before sending it to RabbitMQ, because in HTTP if you see, we also use HTTPS in order to encrypt the message, so that if any person comes in between and steals your message, then he can't decrypt that, because it uses certain kind of encryption using the public key of this server, which only this server can decrypt using the private key of that, which is here, not with user. So this is how TLS, and if you are using TLS, it will also involve certain more packet transfers here and there before you are actually making a connection at AMQP with this RabbitMQ. Okay, and this TLS is a protocol that is a presentation layer protocol. So this is how this actually works. So we have made a connection here. Now in order to communicate to this broker, you will also have to make a channel. Now what I mean by this channel is, this after you have successfully established the connection, you can actually create multiple channels using the same connection. Okay, you will only have to make one TCP connect and all these 7 packets, This only happens once, and you can basically use various channels using this connection. So this connection can be multiplexed, and you can create various channels using this connection, so that you can communicate with this RabbitMQ concurrently using various channels. Okay, so that is why channels are like created, so that there is no need to again do this transfer these packets between these two things, these 7 packet plus acknowledgements again and again, because it's a heavy operation. This thing is a heavy operation. So in order to avoid that, this connection can be multiplexed. And for creating this channel also, it involves 2 TCP packets and certain more acknowledgements also if required. And it's also possible that these TCP packets are again broken further at network layer according to the medium that you are using. So that is something I'm not talking about. I'm talking about the packets till here, not the broken packets after this. So 2 TCP packets are required for creating the channel. Now suppose, let's say there is an exchange that you have created using the management console of RabbitMQ, because what I mean by management console is when you install RabbitMQ on your server, this RabbitMQ actually provides a UI interface also. Using that, you can also modify the configuration of this RabbitMQ. You can create the exchange, you can create queues attached to this exchange, and a lot of things are happening over there. Okay, you can create a lot of stuff there. So suppose, let's say from this management UI, you have created one exchange and the name of that exchange is E1. Okay, now once you have established a connection and then created a channel, what you will do is now you can actually publish a message to this exchange. So now you can actually publish a message to this exchange, and this publish also involves this publish also requires at least 1 TCP packet plus acknowledgements, right? So this publish, right, this publish command will of course construct a packet at application layer. This will have certain more information about this publish command, and it will be pushed over to the medium and it will be reached to the exchange. So you will have to basically provide the exchange name over here. While you are publishing, you will have to provide the exchange name and the payload which you want to send, and this will basically publish the message over the exchange, right? But while publishing the message, you will also have to provide certain more information, and that is because this exchange can be of various types. One is direct exchange, and what I mean by this direct exchange is, suppose let's say you created one queue with the name Q1, okay, and now you want to bind this queue to this exchange E1. So this queue is listening over the messages that are being forwarded to this exchange. So in order to make a connection from this queue to exchange, which is internal to RabbitMQ, you will have to make a binding here. And in order to make a binding, you will have to provide the routing key, or we can also say a binding key. And when you are declaring the exchange, you must have specified that this is a direct exchange. So when the queues which are binding to this exchange, they will have to provide a binding key or routing key in order to bind to this exchange. So you will have to provide a routing key. And suppose let's say this routing key, in your case, what you have done is you have provided like e1.q1.message. This is the routing key. Okay. So when you are publishing the message over this exchange, since it's a direct exchange, you will also have to provide one more parameter over here, and that is basically the routing key. And here, since you want to route it to specific thing, you will say the routing key is e1.q1.message. So this exchange will see, okay, Since the routing key of this message is e1.q1.message, so exchange will forward that message to this queue and not this queue, because this queue has the binding and the routing key of this exchange of this binding is different. This is e1.q2.message. Right now I have created this binding like this, but it can be anything, okay, which you want, but it should be like in this format, like dot dots, okay, but you can put anything here. So this is a kind of binding. This is the direct exchange I'm talking about. So here it will be specific to a particular queue. Now if I talk about another type of exchange, default. Now what this default exchange will do is, when you start a RabbitMQ, it normally has the default exchange. Okay, by default it has exchange. So suppose, let's say if you are forwarding the message, like you are publishing the message to this default exchange, what will happen is you will also have to specify the routing key here. Now what this default exchange will do is, it will create a queue automatically, and this queue name will be the same as the routing key. Okay, and this binding will also have the routing key which is same as this thing, equivalent to queue name. So this is how a default exchange will work. Third exchange that is present over here is topic exchange. This topic exchange is nothing but it is very similar to this direct exchange, but it also has various other functionalities. So in this case you have a flexibility. Suppose, let's say you want to send a message you want a message to be sent to these two queues directly. So this can happen over this topic exchange because it has the functionality of hash and star. So now what will happen is, suppose, let's say when you are publishing the message, inside this routing key, what you have done is, instead of providing the exact name of routing key, you can specify here star. So all the queues which are bounded with this exchange with routing keys similar to this regex expression, all these queues will receive that message. Now if you see here, the routing key of this q1 is e1.q1.message. So this is star. So this will be routed to this message, and then exchange will see, okay, this routing key is also matching with this also, since it's star here, so it will be routed to this queue also. But if we use this hash instead of the star, then you will also have to specify after this dot also, because it divides the key on the basis of this dot. So you will also have to specify message here, or you can also specify a hash here if there is another queue with something different after this. So suppose, let's say the routing key is this e1.hash.message, then also it will be routed to both the things, because the only thing that is different between these two routing keys is this thing. So this is the topic exchange. Now there is another exchange that is called as Fanout exchange. What this Fanout exchange will do is, if you are declaring the exchange as Fanout exchange, if you are declaring an exchange as Fanout exchange, then what will happen is, if you are publishing a message, if you are specifying this routing key, it will be ignored, and even if you do not specify the routing key, it's fine here. So what will happen is, all the queues that are attached, that are bounded to this exchange, all queues will receive that message. It will be broadcasted to all the queues. So it is useful in case of broadcasting. Alright, now there is one more exchange that is called as headers exchange. So in case of topic and direct exchange, we were using this routing key to route the message to specific queues. But now instead of this routing queue, we will use headers to route the message. So let's take an example of that. Suppose, let's say this publisher publishes the message. This is the message. This is the exchange name first of all. Then this message. And then you will also have to specify headers. Now this headers will have, it will be a kind of a object type which have key value pairs, which has key and value. Alright, so now suppose let's say this Q1 and this Q2 are attached to this exchange with headers. Suppose let's say here the headers were A, B, C, D. Now when you have binded this Q1 to exchange, you have specified certain headers over here. So suppose let's say here you have specified certain headers here. Let's say A, B, C, D, E and F. And while establishing the binding over here, you have C, D, E and F. So when this message is published over this exchange will see, okay, since it's a header exchange, it will first of all see the headers, what has been passed in this published thing. So it will see that, okay, A is to B and C is to D. So it will check first this binding. This has A is to B and C is to D. So it will forward the packet to this queue. Now it will check the binding here. It will see that A is to B is not present here, but C is to D is here. Even though C is to D here, but A is to B is not here, so it will not route that message here. Since by default in headers exchange, it is configured in such a way that all the headers that are specified in publish method should match with the binding. So there is property here that is called as X match, and by default its value is all. But you have ways you can modify this X match value and you can change this to any. If you are using this any, what will happen is, even though A is to B is not present over here, only C is to D is here. So even though one header is not there, then also it will route the message here. So that is the advantage of using this X match here. So that is according to you how you actually adjust this thing. In case no headers match with the binding headers, only then this message will not route to that queue. Now there is one more thing, one more kind of exchange that is called as dead letter exchange. We can also say it alternate exchange. And about this we will discuss later on when we will actually have a need of using this exchange. Okay. So till now we have covered how this connection is established and how this message is routed from this exchange to different queues. But now we have to think how this queue forwards that message to this consumer. And this X match property is basically defined while you are making a binding between this exchange and queue. This thing is not configurable when you are publishing a message. This thing is specific to the binding when you are connecting this queue to this exchange. So you have to specify this X match property here, not while publishing. Okay. So this exchange will see if the headers match fully or not according to the X match property defined here. And now suppose let's say this consumer is listening to this queue. So this Q1 will forward those messages to this consumer. And suppose let's say this consumer is listening to this Q2, then this Q2 will forward those messages to this consumer. And if you have more consumers like listening to this queue, then it's possible that this Q2 will forward that message to consumer first or second. It totally depends on this queue and it happens randomly whether it will be sending that message to this consumer or this thing. But if you want to make sure that both consumers listen to the same message, so what you will have to do is you will have to make an exchange and route the message in such a way that it will route that message to two queues, and there is another specific queue which is also present here. So suppose let's say if a message is being routed to this Q2, it is also routed to this Q3. So in case, and this connection not required here now, because if message is routed to both the queues, then both the consumer will get that message. So, and here in RabbitMQ, if I talk about, you have the flexibility to create these queues and exchanges inside this RabbitMQ from the clients itself. Instead of using this management UI, you can also create these exchanges and queues from the clients as well, like from consumer or publisher. And you can also tweak a lot of configuration, like by providing headers, message, and a lot of things you can actually configure on these clients itself. So that's why RabbitMQ is highly flexible, and it is user friendly. So that is the advantage of this RabbitMQ, because it's highly customizable and you can actually tweak its configuration as much as possible. So now we have actually covered how this message is routed to this exchange, then to queue, and then to consumer. But you might be thinking, like, since these network operations are not reliable, and that's why we were not using HTTP here, because HTTP also uses TCP, right? The HTTP also uses TCP behind the scenes. So we were saying that HTTP is not reliable because it's possible that these TCP connections can break in between due to any server, in case if any server is down, or maybe this connection is not used for a long period of time. So how can we say that this thing is reliable? Because this is involving more operations here. In HTTP, we were directly communicating with this from one service to another service, but now we have also added one more thing in between. So now more network calls. How we are saying that this is reliable? So now we will see various edge cases possible in each step that we have covered till now, and we will see what are the points of failure, and we will try to see how RabbitMQ actually covers those edge cases if you set a particular configuration for handling that thing. Because for handling the point of failure at each point, RabbitMQ provides various ways or configurations which you can actually set in order to make sure that the message from publisher actually reaches to consumer. So we will see that thing now. Also, in case of consumer, we will have to set up the connection in the same way the publisher made. So in order to make a connection with broker, consumer will also have to make a connection in the similar way as we have made with publisher. Like similarly, all these things will happen here also in order to make a connection, and also consumer will also make a channel here. So here also it will make a channel, and this channel will also involve 2 TCP packets plus acknowledgements if it's required, and 2 TCP packets for connection, 7 packets plus acknowledgements, and then channel. And then in order to consume the messages from specific queue, what it will have to do is it will also have to first create the queue. If queue is not present in the broker, then it will have to create a queue. So create a queue. This will again involve 2 TCP packets plus acknowledgements. For creating the queue, it will have to specify the queue name, and in order to bind this queue to this exchange, it will have to use this command bind queue, and it will have to specify inside this function some parameters like this exchange name, to which exchange this consumer wants to bind this queue to, and also in order to build this binding, it will have to specify the routing key. So if it's a topic exchange, then you will have to specify the routing key, and if it's a topic exchange, you have the option to basically provide this or this as well, because while binding the queue only you will have to specify the star or hash here. And one thing that I told you about topic exchange, I think I said something wrong at that time. So I said that earlier that according to this routing key pattern which was specified in the message will be routed accordingly to different queues, right? Suppose let's say the routing key of this queue is e1.q1.message, and the binding of this is e1.q2.message. So we can't use a pattern here. Suppose let's say this was routed with the key as e1.q1.message. Okay, so we can't use the pattern here. we will have to specify this pattern at the queue binding level. What routing key will you use while creating this binding between this queue and exchange? Suppose let's say there is one another queue, this Q3, which has a binding of E1 dot star. Then this message will go to this queue and also it will be routed to this queue because you have used a star here. But if you have used a hash here, then you will also have to specify something here. You can specify hash here or star here, but that will make the same sense here because it is the last element of this routing key. Or you can also specify this message. So this message will be routed to this and this also. So even in case the routing key of the published message is e1.q2.message, then this message will be routed to this queue, Q2, and as well as Q3 because we have used a hash here. So this is how the topic exchange work. I said earlier wrong, and this is a right way of creating this binding with a pattern here. And this feature is only available in topic exchange. Now if I talk about this thing, and we were here, like while creating the queue, it will have to specify the queue name, and while binding this queue to the exchange, it will have to adjust the parameters according to the type of exchange you are using here. So you can also create an exchange here itself in consumer itself because that is the functionality RabbitMQ provides to clients. These clients can actually create the queues, exchanges, everything from client side itself. But suppose let's say exchange is already there. Now it has to make another queue. It created the queue, but in order to bind this queue to this exchange, for binding this queue, it will have to specify parameters. Suppose let's say it will have to specify the exchange name even. And suppose let's say it's a topic exchange, so it can provide the binding routing key as even dot star or whatever you want, like I discussed here. And if it's a header exchange, then you will have to specify the headers for binding. So this is how you will bind the queue to this exchange. Now moving further, then it will have to call one more function that is called as basic QoS. Basic QoS. This is basically for quality of service that you want. So here also there are several parameters. You can check those parameters in the document because the parameters that we will put here, like prefetch count and all that stuff, we will discuss that later on when we will actually need that. So right now I'm not focusing on this basic QoS. And the next step, it will have to basically start consuming. So it will have to basically call one function basic consume, and it will have to specify the queue name here. So it will start consuming on that queue. Alright, and also it can specify certain more parameters here, like auto acknowledgement equals to true or false, and similarly. And we will discuss about this acknowledgement later on. So now I think we have a clear idea of how this RabbitMQ actually works, how the message is published by this publisher to exchange, and then it is routed to queues, and then queues will forward that message to consumer. And we will have understood about this connection channel. Similarly here also, consumer side also, you will have to make a connection and then channel and then execute certain operations here. So each function I think requires 2 TCP packets at least. Alright, so plus acknowledgement as well. So this is how RabbitMQ actually works. Now our next goal is to basically cover every edge case possible. Like suppose let's say it has published the message, but what if this message is lost, or the server goes down and our message is lost, or what if the message is pushed to this consumer, but this consumer is down and it is not able to consume that message. So how we will handle those cases? So there are certain point of failures. So we will try to cover that and how RabbitMQ provides features to handle those edge cases. So we will have to do certain configuration in RabbitMQ to handle those cases. So we will be covering that next.